Hello, this is the presentation of the paper entitled A Multivariate Approach to Time Series Forecasting of Copper Prices with the help of multiple imputation by chain equations and multivariate adaptive regression splines. The presentation is divided in 5 parts. The first one is the problem description. In the last years, there have been many different attempts to predict metal prices, not only with the help of time series methods like RIMA, but also with the help of machine learning methodologies such as artificial neural networks. This research is in line with previous research performed with the help of machine learning methodologies. The aim of the present research consists on forecasting the future prices of copper, making use of previous prices of this metal and also of the prices of other raw materials. Part number 2: Materials and Methods. In those cases that it has been required, the imputation of missing data has been performed. In order to perform such imputation, a methodology called multiple imputation by chain equation has been applied. This methodology is based on Markov chain Monte Carlo method. The MICE algorithm has been employed in previous research in a very successful way. This method has 4 main steps that are as follows. In a first step, missing values are imputed by a simple method such as replacing them by the mean of the variable that they belong to. Afterwards, imputed values of only one of the imputed variables are removed again. Next, the values of the missing data from the previous step are calculated with the help of a regression model. Finally, the missing values are then replaced with those obtained with the help of the regression model. This cycle is repeated several times. The present research makes use of multivariate adaptive regression splines for data forecasting. Multivariate adaptive regression splines is a multivariate regression technique developed by Friedman. This regression method is employed in order to predict continuous variables. They can be represented as a very simple equation where E is the model error. One of the main advantages of Mars models is that they do not require any a priori assumption about what is the relationship among variables. Mars models are formed by what are called basis functions. The present research has made use of both multiple imputation by chain equations and multivariate adaptive regression splines models. They are used in the way that is presented in this algorithm. In a first step, missing data are imputed with the help of the multiple imputation by chain equation method. Afterwards, multivariate adaptive regression splines models is trained in order to predict the price of copper taking into account all the variables. It means that for a certain moment t, all the variables are employed to predict the price of copper. Taking into account the results obtained in such model, the importance of variables is analyzed. Those variables that are more important are used in order to create models that are able to predict copper prices in advance from 1 to 12 months ahead. With these models, the forecast of copper prices from September of 2018 to August of 2019 has been performed. 3. The database. As in the rest of papers of this special session, the database employed for this study is the one from the World Bank commodity price data. We have employed a total of 72 different variables for this research. In this slide, you can see the variables that are employed and the units in which they are measured. 4. Results. At 12.52% of the information of the database was missing and have to be inputted. Missing information was presented in 22 out of 72 variables. On average, the percentage of missing data in those variables with missing information was of the 41.05%. Please note that the inputted database that we are employing corresponds to the information available from January 1960 to August 2018, as the prices to be forecasted are monthly values from September 2018 to August 2019. After the imputation of missing data, a Mars model was trained using the copper price as its output variable and the rest of variables as input. The R-square of the model of 10, which has a degree of 6, was 0.9965. For the model training, the threshold value was fixed at 10 to the minus 8 power, and the maximum degree of variables interaction allowed was 9. Of a total of 72 variables employed for training the Mars model, only 23 were found to be relevant, and therefore the rest were not included in the mathematical model obtained. This slide presents the variable importance for the copper forecast. As you can see, the most important variable is platinum, followed by zinc. The next step in the process involves training a set of 12 Mars models that are able to predict the copper price from 1 to 12 months in advance. These models use as training information the values from January 1960 to August 2018 of the 23 variables found to be important. The performance of the model is assessed with the help of the root mean square error, mean absolute percentage error, and mean absolute error. The numerical values can be found in the paper, but here we present the chart that shows how the proposed model is able to mimic the real prices of zinc. 6. Discussion and conclusions. This research presents a novel method for the forecasting of monthly values of copper prices in a multivariate way that takes into account the values of copper in previous months and also the values of other raw materials. The main strengths of the proposed algorithms are that it can be applied in a systematic way, that the results are obtained without any decision that requires any kind of expert knowledge having to be taken, and that all the models computed are Mars models. In other words, relationships among variables are unknown for the researcher, and the model can be interpreted as a black box. We would like to remind that, as happened in the case of most of the forecasting methodologies applied in the stock market that try to forecast the evolution of either stocks of raw materials, one of the main weaknesses of the method is that there are many other exogenous variables, like economical and financial news on the firms, political information, etc., that are not taken into account and can have a greater influence over the future prices than those variables considered in the model. Finally, it is also remarkable that this multivariate methodology would be employed in other fields in general, and it could be useful in many other situations. For example, in environmental research, where the changes in the concentration of any pollutant would be affected by the concentration of the rest. And that's all. Thanks for your attention.